For almost 100 years, physics has been living with this massive, fundamental conflict. We've got two incredible theories, general relativity, which describes the huge cosmic scale, and quantum mechanics, which describes the tiny subatomic world. And they just don't work together. But what if the reason they don't agree is because we're not seeing the full picture? What if there's something much, much deeper going on?
And that brings us to the central, really audacious question behind a new idea called thread theory. It asks, what if the very stage of our universe, space-time itself, isn't the bottom layer of reality? What if it's more like a fabric, something that emerges, woven from even more basic, primitive building blocks?
All right, so let's get into it. Let's pull back the curtain on this cosmic tapestry. The theory proposes that our entire reality is built from something unbelievably simple, these primitive, one-dimensional threads. And when you weave them together, they don't just exist in the world, they literally create it.
So first up, we've got the space thread. Now, try not to think of this as a line that's in space. Instead, imagine it's the raw ingredient for space. Each one has a basic property, kind of like the tension on a guitar string, and that property determines how much spaceness it contributes to the weave.
And of course it has a partner, the time thread. This one carries the potential for time, for duration. So when you weave them together, one space thread, one time thread, you get what's called a space-time thread. That's the basic stitch, the fundamental unit of our entire cosmic fabric.
You can see this is a huge shift in how we think about things. For more than a century, we thought of spacetime as this smooth, continuous backdrop for everything that happens. But thread theory says, no. If you could zoom in far enough, it would look more like a pixelated image or a piece of cloth. It's a grid made of discrete individual threads.
And here's where it gets really, really elegant. The laws of physics? They aren't just some arbitrary rulebook that was written down for the universe to follow. In this picture, they emerge naturally from the physical properties of the threads themselves. Their stiffness, their tension, the way they're woven together.
So what about our big constants of nature? Take the speed of light, c. It's not just a given, it pops out from the ratio of the space thread stiffness to the time thread stiffness. It's just the universe's natural exchange rate between space and time, and it's baked right into the properties of the fabric itself.
And Planck's constant, the cornerstone of the quantum world, that emerges too. This time it comes from the product of the thread stiffnesses. Now the fact that both c from relativity and h from quantum mechanics can come from the same underlying properties, well, that's a massive step toward finally uniting these two worlds.
Okay, so this beautiful picture of reality also happens to make a truly stunning prediction. One that could solve what many people call the single biggest mistake in the entire history of physics, the cosmological constant problem.
The key to this is a whole new scale. Not the tiny, tiny thickness of the threads themselves, but the actual spacing between them in the weave. Think of it like the size of the holes in a piece of fabric. This is called the discovery scale.
So how big is this spacing? The theory predicts it's about 27 micrometers. Now that's tiny, right? About the width of one of your skin cells. But in physics, that's astronomically huge compared to the Planck length, which is where our theories usually just give up. And that's the whole point. 27 micrometers is a scale we can actually probe with experiments, like right now.
So why is this such a big deal? Well, our current theories predict that the energy of empty space, the vacuum energy, should be 120 orders of magnitude bigger than what we actually see. That's a 1 with 120 zeros after it. It's the most wrong we've ever been about anything in science. But in thread theory, you don't calculate that energy all the way down to infinity. You just cut it off at this new discovery scale. And when you do that, the number you get perfectly matches what we observe. The biggest error in physics, it just vanishes.
Okay, so if space-time is the fabric, then what's everything else? The particles, the forces, all the stuff in the universe. Well, in this picture, they're not separate objects sitting on the fabric. They are the fabric, just twisted and vibrating in very specific ways.
Let's start with matter. All the particles that make up you and me, electrons, quarks, what we call fermions, are seen as literal knots and braids in the threads of spacetime. Just think about a knot in a rope. You can slide it along the rope, but you can't just make it disappear. It's stable. It persists. And that persistence is what we experience as a particle of matter.
So get this. The electron, the fundamental particle of electricity, the theory says it's just the simplest, most basic, stable knot you can tie in a single thread, a trefoil knot.
And what's absolutely amazing is that its properties, like its electric charge and its quantum spin, aren't things that are added to it. They're direct consequences of the physical geometry of that knot. And what about quarks, the things that make up protons and neutrons? They're a bit more complex. They're like three-strand braids. And this braided structure just beautifully explains some of their weirdest behaviors, like why they have fractional electric charges and why you can never, ever find a quark all by itself. They're literally tangled up with each other.
Okay, so if matter particles are knots, then what are the forces that act between them? They're just vibrations. The particles that carry forces, like photons for light, are nothing more than ripples traveling through the cosmic weave, carrying energy from one knot to another like a pluck on a guitar string.
So now that we have this new foundation, we can zoom all the way out and start looking at the biggest things in the cosmos, black holes, and even the beginning of the universe itself, through a completely new lens.
According to general relativity, at the heart of every black hole is a singularity, a single point of infinite density where all the laws of physics just break. Thread theory says, nope. The core of a black hole is simply an incredibly dense, stable ball of woven threads. It's extreme for sure, but it's finite. There's no infinity, no point where physics stops working.
And this also totally changes how we see the Big Bang. Instead of starting from a singularity, an infinitely dense point, the theory suggests a thread bang. The best way to think about it is like water freezing into ice. The universe went through a phase transition, where a chaotic, super dense tangle of threads suddenly crystallized into the orderly, expanding weave of spacetime we live in now.
And from there, the idea of a multiverse becomes almost obvious. I mean, if our universe is just one specific pattern of weave, what's to stop other patterns from existing? You could have different universes with totally different laws of physics that are just different tapestries woven from the exact same kind of fundamental threads. Okay, look, this is a beautiful, elegant story. It's a fantastic idea. But is it just a story, or is it actual science? Well, the difference is testability. A real scientific theory has to make predictions that we can go out and check. And that's exactly what thread theory does.
That 27 micrometer discovery scale, that's not just a number, it's a target. It predicts that if we can measure gravity very, very precisely at that tiny distance, we should actually see it behave differently than what Einstein predicted. It also suggests we might find weird effects in other quantum forces, or even find specific patterns, like a Weaver's signature, left over in the afterglow of the Big Bang, or in the gravitational waves from colliding black holes. These are real experiments we can do to find out if this whole cosmic weave is actually real.
You know, at the end of the day, this theory leaves us with this really profound change in how we see ourselves and our place in the cosmos. If it turns out to be right, we aren't just living in the universe, we are the universe. Every single particle in our bodies is a complex little pattern in this one magnificent cosmic weave. We're a tiny but conscious part of it all. We might even be the universe's way of knowing itself. And honestly, what could possibly be more incredible than that?